Have you ever wondered why ice cubes float on water? Let's investigate. Picture this: a chilly ice cube slipping into a glass of water. It plunges in, but instead of sinking to the bottom, it bobs back to the surface, almost as if by magic. But it's not magic, it's science. This everyday phenomenon is a result of fascinating rules that govern our universe. Now that we have seen this marvel with our own eyes, let's dive deeper into the science behind it. Enter Archimedes, the ancient Greek philosopher who helped us decode the mystery of floating objects. Picture him stepping into a bathtub brimming with water. As he settles in, the water level rises, right? This sudden eureka moment led him to formulate the principle of buoyancy. Archimedes declared that an object submerged in a fluid experiences an upward force equal to the weight of the fluid displaced by the object. That's why, when we drop an ice cube into a glass of water, it pushes aside or displaces an amount of water. If the weight of this displaced water is greater than the weight of the ice cube floats. If not, it would sink. So the floating or sinking of an object is not about its weight, but about the weight of the water it displaces. With Archimedes' principle, we can begin to understand why our ice cube floats. But there's another key player in our story: water. Water? It's more than just a thirst quencher. It's a scientific marvel. It's a chameleon, changing its density based on temperature. Most substances become denser as they cool, but water, the rebel that it is, behaves differently. At around 4 degrees Celsius, water is at its densest. But as it cools further and turns into ice, it becomes less dense. A bit counterintuitive, isn't it? This lighter density of ice is precisely why it floats on water. The ice cube's molecules, while frozen, are arranged in a hexagonal pattern, creating more space between them. This makes the ice less dense than the water it's placed in. The beauty of this is that it's not just about the ice cube being light, it's also about water's unique behavior. This interplay between the properties of water and ice is what makes our experiment work. So it's not just the ice cube's lightness, it's also water's unique properties that make our little experiment possible.
Now let's see how this fascinating science plays out in the real world, from polar bears to popsicles. You see, the fact that ice floats is critical for the survival of many creatures in the Arctic. If ice sank, it would mean a significantly colder water surface, making it a much harsher environment for polar bears and other Arctic animals. And what about those refreshing popsicles we all love on a hot summer day? Well, the same principle applies. The ice in your popsicle is less dense than the juice or soda it's made from. That's why it floats up, creating that icy layer on top, while the flavor-packed liquid stays below. Isn't it incredible how a simple principle of physics can have such a significant impact on our world, from the survival of species to the enjoyment of a summertime treat? So there you have it, the sensational science of ice cubes floating on water. We've unraveled the mystery of the floating ice cube, but this is just the beginning. The world of science is a vast ocean of curiosities waiting to be explored. Let's keep this journey of discovery going. Share your thoughts, wonderings, and questions. The magic of science is in the questioning and the thrill of finding the answers. Stay curious, stay awesome, and remember, there's more epic exploration coming your way soon. See you in the next video.